Good morning, this is Mrs. Tellas. We're going to be doing section 7.4 today, and we're going to be solving quadratic equations that are already in factored form. We're also going to be starting our factoring journey looking for the GCF, or the greatest common factor in a quadratic, and then solve from there as well. So we're going to do two different things here on 7.4. So the first thing we need to know is if the product of two numbers is 0, what do we know about the two numbers? Well, hopefully you know if the product means multiply, and if we're multiplying two numbers to get, so something times something equals 0. We know that one of them has to be 0 in order for the answer or the product to be 0. And we're going to be using that 0 property today to come up with our answers for solving. So when we're coming up with answers for solving, there's lots of names for them. They call them solutions, roots, zeros, and x-intercepts. So we could call our answers today any of these. All right, so if we do the first objective here, solving a quadratic. So this looks like we would FOIL it from 7.2, but we're not going to FOIL it. This is in factored form. It is a quadratic that's in factored form. And we will spend a great deal of time learning how to factor those. We've been spending time learning how to multiply them and FOIL them and use a Punnett square. Now we're going to spend some time learning how to solve them. So what I do is I take each one of the parentheses separately. So I'm going to start with t plus 1, and I'm going to set that one equal to 0. So t plus 1 equals 0. And that is just a one-step equation. So I'm going to make my t, and to get rid of a plus 1, we subtract 1 on both sides. So the t is going to drop down below the line. Plus 1 minus 1 cancels, equals drops. And over here, 0 minus 1 is negative 1. That is one of the solutions, or roots, or zeros, or x-intercepts. That's one of the answers. There's another answer. So I have to take the other parenthesis, t minus 2, and do the exact same thing. So t minus 2 equals 0. So I'm going to make my t and add 2 on both sides. The t drops down. The 2's cancel. Equals drops, and 2 is the other answer. So the solution set is negative 1, comma 2. There's two answers. And I know that there's two answers because there's two different parentheses, or two t's in the problem. So if I do the second one, it's exactly the same. They're already factored. There's two parentheses or binomials. So I'm going to set the first one equal to 0. So 2y plus 1 equals 0. So this is a two-step equation. So I make my t. I'm going to get rid of that plus 1 by doing the opposite, which is minus 1, both sides. The 2y is going to drop. The 1's cross out. And it equals negative 1 over here. And then to get rid of this 2, I have to divide by 2. So my answer here is either negative 1/2, or if you want to put it in as a fraction, you would type in negative 1 divided by 2. That would be negative 0.5. So both of those are correct in the answer to this first parenthesis. And if we do the second parenthesis, the second one's just a little bit easier. Y minus 14. So this is just a one step. So I'm going to add 14 to both sides. And that one is 14. So my solution set would be negative 1/2 and 14 for my two answers. Okay, on number 3, remember that quantity squared there means that there are two of them. X minus 9 and x minus 9 equals 0. So I'm going to set them both equal to 0. And you notice since they're exactly the same, they're going to give me the same answer. So I'm just going to do it once. So x minus 9 equals 0. So add 9 and add 9. So x is 9. Now I could, if I wanted, do the other parenthesis, but I hope you see that it's exactly the same thing. And it would give you the exact same answer. So the answer here is just 9. Okay, or the solution, or the roots, or the x-intercept. Okay, and then here, notice that there are 3 C's. Notice there's a C in the front, a C in the first parenthesis, and a C in the second parenthesis. So I'm going to set, there's going to be 3 answers here. I know that because there are 3 C's. Up here, I knew there were going to be 2 answers because there's 2 T's. Here there would be 2 answers because there's 2 Y's. Here there would be 2 answers because there's 2 X's. Even though it's the same answer, it's still 2 answers. So here I would do 5C equals 0, C minus 4 equals 0, and 3C minus 2 equals 0. So each of them are going to produce their own solution. So on this first one, if I want to get rid of the 5, I divide both sides by 5. So my first solution is 0. On the second one, I'm going to add 4 to both sides. And on the last one, I'm going to add 2 to both sides. Pull the 3C down and divide by 3. So I can leave that as 2/3, or I could type that in as 2 divided by 3, and that would give me 0.6 repeating. I like the fraction better. So my answer or my solution set would be 0, 2/3, and 4. And it doesn't really matter on the order. You can put them in whatever order you want. I just put them in numerical order. Okay, so I've got some for you to hit pause and give them a try. So here you're going to have 2 solutions because there's 2 X's. Here you'll have 2 solutions because there's 2 N's. Here you'll have 2 solutions because there's 2 N's. And on this one you'll have 1, 2, 3, 4 solutions. I would like you to hit pause and try all 4 of these right now. So if I go through the first one, I'm going to set this first equation equal to 0, or expression. So x plus 6 equals 0. So if I get x alone, I would have to subtract 6. And then I would set the other one equal to 0. So x minus 4 equals 0. So I'm adding 4 to both sides. So x is 4. So my 2 solutions on the first one are -6 and 4. I hope you got that. If you did, give yourself a pat on the back. All right, if we do the second one. So this first one has to be set equal to 0 because it has a letter in it. So n equals 0. Well, that's already solved. I don't have to do anything to solve that. So then I'm going to set the other one equal to 0, 2n minus 5. If I solve this one, I'm going to add 5 on both sides and divide by 2. That's going to give me 2.5 or 5/2. I kind of like it as 5/2. So my answer or my solutions or my roots or my zeros, my x-intercepts are all the same thing. It's 0 and 2.5. Okay, if I go to number 7, I'm going to set both of the letters equal to 0, this one and this one. So 5n equals 0. So I would divide by 5 to get 0. And 5 minus n. This one's a little tricky. So the first thing I have to do is subtract 5 on both sides. And I have to pull the negative n down. The whole thing comes down. And then I have to divide by -1. So the 2 solutions on number 7 are 0 and 5. That one was a little tougher. I got to remember those solving skills. And then on this last one, this is not a quadratic. This is a much bigger equation because it's got 4 x's. There's going to be 4 answers. So I'm going to set the 2x equal to 0, the 5x minus 3 equal to 0, the x plus 4 equal to 0, and the x minus 1 equal to 0. So here I'm dividing everything by 2. My first solution is 0. The second one, I'm going to add 3 to both sides of the equation and then divide by 5. So my second part of the equation is 3/5, or if you put that in as a division problem, it's 0.6. On the third one, I'm going to subtract 4 on both sides, and I get -4. And on the last one, I'm adding 1 on both sides, and I get 1. So my solutions are 0, 3/5, -4, and 1. And again, those don't have to be in any particular order. Okay, this is where this particular equation will cross the x-axis, or it's its roots, or its zeros, or solutions. Okay, so hopefully you were able to do that. All right, this is the second skill, factoring using the GCF. So when you look at these, notice that there aren't any parentheses. They're written out like they would be if you had already multiplied through or done FOIL, or you have to factor them. So we're going to make them have a parenthesis. So what we were dealing with before had parentheses. Now we're going to make these have a parenthesis. And the GCF stands for the greatest common factor. All right, so first I look at the numbers, 4 and 16. Okay, and I need the highest number that will be divided out of 4 that can also be divided by 16. And that's going to be 4. 4 can be divided out of 4 and 16. So I'm going to put my 4 in the front. So far I'm dividing both of these by 4. Okay, now I'm going to look at the x's. And I need the most amount of x's that can be divided out of both of these terms. Well, in this particular term, there's 2 of them. X squared means there's 2 x's, and this means x to the first, okay, where there's only 1 x. Well, I can't take 2 x's out of this one, but I can take 1 x out of both. So I'm going to divide x out of both of them. Okay, so 4x is going to be in the front of my factored form. All right, so 4 divided by 4 is 1, and x squared divided by x is x. Okay, if there are 2 of them and I divide 1 out, I have 1 left. You remember your division rules from chapter 6, we do 2 minus 1 on like basis. Okay, and then negative 16 divided by 4 is negative 4, and x divided x cancels completely. That's a 1, but we don't write a 1. Okay, we already have the 4 there. So this is my factored form right here. Okay, so let's try another one. Let's look at this one on letter 8B. So let's start with our numbers first. Oops. Let's start with our numbers first, and we're going to look at what's the highest number that I can take. I can divide 3 and 12. I need to be able to divide the same number out of both of them. Hopefully you're thinking that it's 3. So I put a 3 in the front with a parenthesis. So I'm going to be dividing by 3 on both of them. Remember, whatever I divide by, I have to be able to divide both of them by that number. Okay, and now I'm looking at the a's. Well, this one has an a squared, but this back term doesn't have an a. So I can't divide any a's out, so it's just going to be 3 on the outside. So 3 divided by 3 is 1. So that's 1a to the second. And positive 12 divided by 3 is positive 4. Okay, so this would be my factored form. Now, you don't need this 1 here. I should have done that in the first one. This should just be a squared plus 4. But I will take this either way. I'm not sure if big ideas will take the 1 or not. But I would probably rewrite this first one like this as a more correct answer. This one's not wrong. We just don't usually write that 1 right there. It's implied. All right, I want you to go ahead and press pause, and I'd like you to try both of these and see if you can come up with it. Okay, so I'm going to try to take the highest number out of 15 and also out of 12. The largest number I can think that I can divide out of 15 and 12 is 3. And the most amount of x's I can take out is x to the second. So that's what I'm going to divide out of both of these. 3x to the second and 3x to the second. So 15 divided by 3 is 5. X to the third divided by x to the second is x to the first. 3 minus 2 is 1, and I don't usually put that 1 there. Okay, negative 12 divided by 3 is negative 4, and x squared divided by x squared is x to the 0, or it cancels. So this is my answer right here. I'm going to scoot this parenthesis up. This is my answer. Okay, on number 8, there is no number besides 1 that can be divided out of 7 and also negative 6, so there's no number that I can mess with. However, there are 4 b's here and there are 2 b's here, so that means I can divide out a b squared from both of them. So b squared is going to be in front of the parenthesis. So there's a 1 here. 7 divided by 1 is 7. And b to the fourth divided by b to the second, I subtract exponents, that's b to the second. Okay, minus 6, because again, there's a 1 there. Negative 6 divided 1 is negative 6. And these are exactly the same, so they cancel. So this is the answer to that one. Be careful, the B's and the 6's look the same. That's a 6 and that's a B. So I hope you understand how to do that. There's more practice in the book for that if you're needing some help. Okay, so now we're going to factor what we just learned how to do, and we're also going to solve. So we're going to put our first skill and our second skill together in the same problem. So notice there's no parentheses that I can just set equal to 0 and solve. It's already like that. So I need to pull some parentheses out. I need to find the GCF since there's only 2 terms. So the highest number that can be divided out of 2 and 8 is 2. And the most amount of x's that can be divided out of x squared and x is x. So 2x is what I'm going to be dividing both of them by. And what's on the inside is what's left when I divide. So 2 divide 2 is 1. X squared divide x is x. I don't need that one there. I'm going to rewrite it here in a second without it. Plus 8 divide 2 is 4. And x divide x is 1. Okay, it's x to the 0, which is 1. Okay, so my equation is 2x times the quantity x plus 4 equals 0. So now I can go back to what I was doing before, setting both of these equal to 0 and using my solving skills. So 2x equals 0 and x plus 4 equals 0. So if I divide by 2, my first solution is 0. And if I subtract 4, my second solution is negative 4. So my 2 solutions or roots or x-intercepts or zeros, this is negative 4 and 0. Okay, I would like you to press pause and try number 10 by yourself. Okay, this isn't new. It's new in the fact that we learned how to do both of these skills, but it's not new. We're putting 2 skills together that we already know how to do now. So I would like you to try number 10 by yourself. Press pause, please, and try it. All right, the highest number that I can divide out of 8 and 24 is 8. And the most amount of y's I can divide out here is y. So I'm going to divide both of these terms by 8y. What's left inside the parentheses? 8 divided by 8 is 1, and y squared divided by y to the first would just be y, or y to the first. And I really don't want that 1 there. I can put it, but I don't need it. All right, and then negative 24 divided by 8 is negative 3, and those y's cancel. So now I can set them equal to 0. The 8y gets set equal to 0, and so does the y minus 3. So 8y equals 0 would be 0, and y minus 3 would be positive 3. So my 2 solutions are 0 and 3. Okay, so if you got that right, nice job. All right, so notice on 11 and 12, they look a little different, only because they're not exactly set equal to 0, and they need to be. So I hope you can remember, if we want to move that 15n over here to this side of the equation, I could make a t, and how do you move a positive 15n? Well, I hope you thought I can minus it on both sides. So now I have the equation 6n squared minus 15n equals 0. Okay, so now I need the highest number that I can divide out of 6 and negative 15. Well, the highest number I can think of is 3. And the most amount of n's I can take out of n squared and n is n. So I'm dividing these by 3n. So in the front term, that leaves me with 2n minus 5. So each of these will be set equal to 0, just like we were doing at the beginning of the lesson. So 3n equals 0, and 2n minus 5 equals 0. So here I divide by 3. First solution is 0. And here I add 5 first, and then I divide 2 second. So I get 5 over 2, or 2.5 if you'd rather have a decimal. I'm going to leave it as a fraction. So 0 and 5 over 2 is my answer. I'd like you to press pause and try this next one, please. See if you can come up with it. It's just like the one above. If you want to rewind and watch that one again, notice how I moved the 15n over by subtracting. You're going to do the same thing with the 18x. Give it a try. Okay, so first thing I want to do is move this 18x over here. It's a positive since there's no sign, so I'm going to subtract 18x on both sides. That leaves me with 16x squared minus 18x equals 0. Do you remember why we can't add the 6 and the negative 18? They're not like terms. The x squared is different than the x. That's why we can't add them together or subtract them together. All right, so thinking about my greatest common factor, the highest number that can come out of a 6 and 18 is a 6. And the most amount of x's I can take out of x squared and x is x. So this is x minus 3 equals 0 on that inside. So now I can set both of these equal to 0. Anything that has an x gets set equal to 0. So 6x equals 0. So again, our first solution is going to be 0. It's been like this on this whole page. And then the other one would be x minus 3 equals 0. So I end up with x equals 3. Now my two solutions for this are 0 and 3. So I hope that's making sense, and I hope you got it right. If you didn't, I hope you found your mistake. Finding your mistake is super important so that you don't make it again. All right, let's look at the next set. Okay, there's a few of these in your book too. Now remember, what did we call the solutions, the answers? We call them solutions. We call them roots. We call them zeros. And we also call them x-intercepts. Okay, so if you look at this picture, this is a parabola or a quadratic equation, just like most of the ones that we just solved. The answer is right here, where the point or where the parabola crosses the x-axis, and this is the x-axis. Now it's hard to tell because these x-axis is by 3's, but they give you the equation right here. So you're going to set each one of these equal to 0, and that's going to give you the two exact answers or solutions. So x minus 8 equals 0. So my first solution is 8. That would be this one right here. And then my other solution, x plus 8, I'm subtracting 8 on both sides on that one. And that's this one right here. That's my negative 8. So the two solutions on this picture or this equation or this quadratic equation is 8 and negative 8. Those are my two answers. So your turn. You try. Notice this parabola is pointing or opening downward, kind of like a frowny face. Okay, notice that last one that we did was kind of like a smile, okay, or opening up. Okay, so let's look at this one. So here's your equation down here. Again, it's hard to tell because it looks like the x-axis is going by 4s. 0, 4, 8, 12, 16. Okay, but we can tell because of these two equations, or the two expressions that they give us in the equation. Okay, now remember, you only set things equal to 0 that have an x in them. Okay, and we change this y to 0 so we can figure out what the solutions are. Right, I don't worry about this up here because it doesn't have an x, so it's like it's not even there for me. All right, so x minus 14 equals 0. So if I add 14 to both sides of that equation, my first solution is 14. So that's going to be this one right here. And then if I switch colors, the other one is x minus 5 equals 0. So that one is 5. And you can see it's that one right there. So these answers actually mean something. They're not just random numbers. It means where that particular quadratic equation crosses the x-intercept, which is why we call them x-intercepts in addition to roots and zeros and solutions. Okay, so I'm all finished. I hope you are now able to solve using the GCF and then solve those quadratic equations by setting them equal to 0 and using those solving skills that we worked so hard on in Chapter 1. So your assignment is in Big Ideas. It's page 381, 3 to 39 odds. I would very much like you to do this online in Big Ideas if you can. Okay, so if you haven't been there yet, you're going to go to the Perry Township website. Then you'll go to the resource portal. Then you'll go to evaluate. And then find your Big Ideas app. And on the Big Ideas app, you're going to look for where it says assignments. And for this particular assignment, you'll look for 7.4 because this is that section. All right, so Canvas conferencing hours are between 12 and 1. I'm sorry, for double block, it's between 11 and 12. Lots of you are taking advantage of that, so I'm proud of you. Nice job. I hope to see you. I hope to see you today after you watch the video. So take care. I hope all is well. Bye bye.